Hey guys, how you doing? This is Coach Scott. I wanted to go over question 6 on worksheet 1, mainly because it seems sort of hard. All right, there's a lot of reading here, but if you break it down, it's not that hard. So if you read it, the recipe for Coca-Cola Classic is a closely guarded secret. Researchers outside the company believe that the flavoring mixture known as 7X, I didn't know that, contains oils of orange, lemon, nutmeg, cinnamon, and coriander. It might. The original mixture also contained caffeine, vanilla, caramel, lime juice, sugar, or artificial sweetener, and citric acid. Also heard it used to contain cocaine. That's where Coca-Cola came from. Over the years, the recipe has changed. For example, the original recipe contained citric acid, but this was combined with phosphoric acid to cut production cost. Eventually, corn syrup replaced sugar for the same reason. So I've got a nice little formula here. You can see there's 1 mole of caffeine is used with 4 moles of phosphoric acid, 6 moles of carbon dioxide, and other ingredients produce 1 mole of potassium benzoate and other products. Whoa, that looks difficult. So to produce 100,000 cans of Coca-Cola Classic, 40 grams, 0.21 moles of caffeine are reacted with phosphoric acid and other ingredients. How many moles of phosphoric acid are required? How many moles of carbon dioxide are required? Okay, I've got a simple BCA table. All right, so I've got 1 mole caffeine, and I'm just going to write it down here. All right, is going to react with 4 moles of H3PO4 and 6 moles of carbon dioxide and other stuff. Those are dots. To produce 1 mole of potassium benzoate. So it gave me that I've got 0.21. Let's write our B, C, and A. So before the reaction, before we produce this, okay, I've got 0.21 grams, or 40 grams, or 0.21 moles of caffeine. Again, they took the 40 grams and converted it into moles. So in other words, what they did is divided the 40 grams by the molar mass of caffeine, and we could calculate it, and we got 0.21 moles. I reacted with phosphoric acid and other ingredients. So for every 1 mole of caffeine, I need 4 moles of phosphoric acid. So for 0.21, that means I'm going to have more phosphoric acid than caffeine. So when I multiply the 0.21 of caffeine by 1 over 4 or 4 over 1, well, I need it to be bigger, so of course I'm going to multiply it by 4 over 1. So 4 times 0.21, I got 0.84. So that means I need 0.84 moles of phosphoric acid. So how many moles of carbon dioxide? Well, I need 6. Of course, it's going to be more of that. So I'm going to multiply 0.21, either 1 over 6 or 6 over 1. Of course, it's 6 over 1. So I'm going to multiply that by 6, and I get 1.26 moles of carbon dioxide. Seems like a hard problem. It really isn't. Actually, it's probably one of the easier ones on the sheets. Right? So how do we change it? Well, once we make our Coca-Cola syrup, that's going to go down to 0.21. That's going to go 0.84. And that's going to minus 1.26. Out of curiosity, how many grams of potassium benzoate is it going to produce? Well, it's a 1-to-1 ratio, so it's going to produce, as a 0, okay, it's going to produce 0.21 moles of potassium benzoate. Not hard. All right, guys, there's question 6. Don't let it scare you. And this stuff is not hard, I promise you. Okay, guys, this is Coach Scott saying what? Hullabaloo, connect, connect. Have a great day.